So today we're going to use the graphing calculator to graph some of the lines that we've done previously. So take a minute, make sure you turn your graphing calculator on. What we're going to do is we're going to start by graphing the line 4x plus 2y equals 10. So notice that on the calculator, when we go to the home screen, we're going to choose the graph. And the graph symbol is this little graph-like icon. So when you go to your home screen, work your way down and select graph. And notice that a grid appears, and also an entry line appears that says f1 of x. We pronounce it as f of x. And really, that's just the idea that this f is the same as saying y equals. We use the letter f to represent a function, and we'll talk about function later on. But for right now, when you see f1 of x, I want you to think y equals. So now we're going to graph the line 4x plus 2y equals 10. But notice that the first thing we got to do is we have to take the expression that's solved for y. So we've got to solve this for y equals. So I'm going to take this 4x plus 2y equals 10. We'll subtract 4x from both sides. And when I do that, I'm going to put my negative 4x first, because I like to try to put in y equals mx plus b form. I'll divide everything by 2, and I'm going to get y equals negative 2x plus 5. Now, you probably have an idea about how to graph that equation already. You know what the slope is, you know what the y-intercept is. So let's just make sure that it appears that way in our graph. So over here, we'll type in negative, make sure you use the negative sign, negative 2x plus 5, and press enter. And your line appears. And sure enough, it looks like it has a y-intercept of 5. It has a negative slope. So it looks pretty accurate. It looks like one that we would graph on our paper. Speaking of graphing it on our paper, one thing we can do is we can open up a table of values. So if I press Control and T, I'll get a table of values that shows up as that old list and spreadsheet from before. And moving my cursor around, I can find, for example, the y-intercept, and I can find a bunch of different x and y values. So in this case, when x equals 0, the y value is 5, and so on. So I'm going to go to my graph, and maybe I'll make my table of values. I knew that when x equals 0, y equals 5. When x is 1, y is 3. When x is 2, y is 1. When x is 3, y was negative 1. So now I got my table. I do what I did before. I plot my points. 0, 5, 1, 3, 2, 1. I can follow my pattern of keep going down 2 and to the right 1. Or from the y-intercept go up 2 and left 1. You'll use a straight edge to draw a nice line there. We'll label it 4x plus 2y equals 10. Perfect. Or you could use the label y equals negative 2x plus 5. Either one is good. To get rid of the table, press Control T again, and your table is gone. So back here real quick, you see some of the steps to transfer to the graph paper, how to get your table of values, how to hide the table as well. So let's take a look at another example just to get some more graphing practice. So here's one of the contextual ones like you had from a day or two ago. Sam leaves Buffalo, he's driving towards Albany, they're 270 miles apart. Sam's driving 70 miles per hour. So we're going to write this equation to model the distance from Albany. Okay, so it's a distance from Albany. So he starts at Buffalo and is getting closer to Albany. So then his distance is going to be starting at 270. And now because he's getting closer to Albany, his distance is decreasing. This rate of 70 miles per hour, that slope is going to be represented as a negative slope. So like you did before, the equation d equals negative 70t plus 270, that's a great equation to use. But the calculator likes y and x. So when we go to graph it, let's graph y equals negative 70x plus 270. That's the way the calculator likes it better. So I'm going to go to the calculator first. Maybe I'll go Control N. We'll get a new graph going. Add a graph there. And we're going to type negative 70x. Remember, the calculator likes x and y. Plus 270. Okay, that graph's a problem because it looks like it's almost a vertical line. I can't see the y-intercept. My scale is off here a little bit. So watch what I'm going to do here. This is pretty neat. I know that I want my y-intercept to be around the y-intercept is 270. So on my graph, I want it to be a little bit more than 270. If you notice this number right here and the number out there, those are the values that tell you what the maximum x and the minimum x and the y's are. We can change those. So what I'm going to do is I'm going to double click on the 6.67 up top. And what I can do then is I can delete that number. And what do I want it to be? Well, the y-intercept is 270, so let me go a little bit above that. Let me go up to, say, 300. And then when I press enter, now I can see where my y-intercept is. So my graph is looking pretty good. I might make it look a little bit better, though. For example, see that negative 10 in the bottom left corner? It doesn't make sense for time to be negative 10 hours. So I'm going to double click on that. I'll delete that. Let's make that maybe negative 1. And I'd like negative 1 only because I can see where the y-axis is then. If I put 0, then the y-axis is covered up by the calculator screen. And likewise, that 10 here on the bottom right, I don't need to really go out to all 10 hours. It looks like, based on my graph, I might need to go only, it looks like this value where the graph crosses the x-axis, this little value down here. It looks like it's probably a little less than 5. It looks like it's less than halfway. So I'm going to change that to 5. And that graph looks a little better. It tells a little bit of a better story. So now, why don't we fit this to our graph? First, what I want to do is I want to make an appropriate scale. So what I did was on my calculator, I went from about negative 1 or 0, say, out to 5 on the x-axis, and the y-axis went up to about 300. So when I go to my graph here, let's start down here at 0. And let's go up to 300. Now, on these grids, they are 20 boxes apart. So if I do 300 divided by 20, I'm going to get 15. So that tells me that if I make each box 15 going up, that's going to be a good scale. Now, I don't think I'm going to write in every one. I might write every 2. So let's say that's 30, 60, and 90, 120, 150, 180, 210, 240. Here's my 270. I know that's my y-intercept. So this is going to be my distance. Now, on the bottom, for my time, I know that I want to go out to about 5 hours. Again, I got 20 boxes. So if I make each box maybe a quarter of an hour, so that 4 boxes is 1 hour, that's going to space it out pretty nicely as well. So here's an appropriate scale that's going to show all the important parts. It's going to show the y-intercept. It's going to show where the graph crosses the x-axis. If I go to my table of values here, remember table is Control T. My y-intercept is at 0, 270. And then I have a couple of the values here as well. So I'm going to plot some of those on my graph. I have 0, 270. When x equals 1, I was at 200. So 200 is probably going to be about here. When x equals 2, we had 130. So 130 is going to be about here. When x equals 3, I have 60. Oh, that's good. As long as I have 2 points on my graph, I can connect them with a line. And what I'm going to actually do is I'm going to use the line part of my smartboard to draw that graph, because I want to make sure it goes through that point 360. So that looks pretty accurate there. That looks like a nice line there. So my distance equals negative 70t plus 270. Now, here's where the calculator really comes in handy. I want to show you a couple things that you can do on the calculator that's really going to impress you. So our next question we have here is, how far from Buffalo is Sam after 1.5 hours? So I'm going to let the calculator help me with that. I'm going to introduce a new function to you called trace. I'm going to Control T from my table. Now, if I press Menu and choose 5 for trace and then 1 for graph trace, what graph trace does is it allows you to determine values that are on your graph. For example, it's telling me that the point that's shown right here in that circle has the coordinates 2, 130. So that means that after 2 hours, I'm 130 miles away. Well, I wanted 1.5 hours. So if I type in 1.5, you see how in the middle it says x equals 1.5? The calculator is saying, oh, you want the y value when x is 1.5. Press enter. It moves the point to where it belongs, and at 1.5, the distance was 165 miles. So that's how we can use trace. You can tell that you're in trace because of this little icon up here on that top left. That's the trace icon. So if you want to get out of trace, you can press escape, and I'll get out of trace on that. Trace is a pretty neat thing. So what we found out was after 1.5 hours, we were 165 miles. Now here's another really good one. After how many hours does Sam reach Albany? When he reaches Albany, his distance from Albany is 0. So on the calculator, I'm going to do a function called 0. I'm going to press menu, and I'm going to this time go to Analyze Graph. And Analyze Graph has an option called 0. So basically what I want to tell the calculator is to determine the value of that point there. So first the calculator is asking me for a lower bound. This dotted line is on the left side, so I'm going to press enter here. It's on the left side of my 0 where my graph crosses the x-axis. My upper bound, so I'm going to move my line over to the right, and once I cross over that value, boom, there's my 0. And now I'll just press enter. So what it's telling me is that the 0 of the graph, where it crosses the x-axis, occurs with an x value of 3.86. So that's the function called the 0 function. We did trace up here to get 1.65, and then we went to 0 to get 3.86 hours until Sam reaches Albany. So those are two neat things. So let's do a quick wrap-up. First of all, the easy way to change that window size. Remember those little numbers? Click on the scale on the axes. That was a nice, easy way to change the window. You click on it, type in whatever number you want. The trace function. Remember, trace is going menu, and then 5, and then 1 for a graph trace. Trace allows you to find a y value when you're given x. So we used trace. We said after 1.5 hours, how far is Sam from Buffalo? X was 1.5. We typed in x, and we got the y value. And the last part, where the graph crosses the x-axis, that's that function called 0. And we wanted to do menu, and then 6, and then 1. And then remember, we got to do lower bound and upper bound there as well. So hopefully this helped you with graphing a line on the calculator and using two really good functions, trace and 0.